Hi, good morning, students. As we are discussing our chapter, that is our HCl, hydrochloric acid. We are discussing its all the kind of properties as well as its different types of formation, that is the laboratory preparations of this HCl, as well as we are discussing what are the conditions required for the formation or the preparations of this specific compound, that is HCl. As along with this, we need to find out some reactions. Okay, very few reactions of this HCl compound, that is all with a metal, with some metal oxide and rest of the things. But the very important part in this HCl compound is the very first thing is its fountain experiment. That is the fountain experiment which we start today, that we are going to study this fountain experiment. And the second thing is the formation of hydrogen chloride, the formation of HCl, that is an acid which is called as your hydrogen chloride. Because in the previous video, in the last lecture we are studying the formation of a hydrogen gas. This is a hydrogen gas, and from this hydrogen gas we want to prepare that hydrogen chloride, that is your acid, that is the hydrogen chloride or hydrochloric acid, which is also called as your hydrochloric acid. We want to prepare this. So for the preparation of this hydrochloric acid, we just required a specific conditions for that, and we require a specific arrangement for the preparation, and that arrangement is very necessary and many questions are coming on that arrangements. So let's start our today's lecture, and just we are discussing all these things. So let's start the things. Okay, just we are starting the things here. Okay, just within a 1 second we'll start our things. Just 1 minute. So the very first thing here is the test for your HCl gas. That is test for the HCl gas, that how you going to test the presence of this HCl gas. So to test this presence of this HCl gas, you need to bring just a glass rod. Okay, you required only two things: glass rod. The second thing is your ammonium hydroxide solution, that is your ammonium hydroxide, and that ammonium hydroxide is nothing just NH4OH part that you required, plus your HCl gas. As such, your HCl gas is required. Just you need to do is one thing: just take a glass rod, dip that glass rod in a beaker, and that beaker containing the solution of this ammonium hydroxide, that is the solution of NH4OH. Just do one thing: dip this glass rod, that is your glass rod present, dip this glass rod with this solution, and after just dipping, bring this glass rod to a jar or to a beaker which is already containing your HCl gas. And you know what, that HCl gas, as well as you are just taking this dipped glass rod with ammonium hydroxide, on the upper portion of this HCl gas there are certain white fumes present. Here the white fumes are present, and that white fumes are due to the formation of a compound, that is ammonium chloride here. And that ammonium chloride is formed, this ammonium chloride will be formed by the reaction of this ammonium hydroxide along with our HCl gas, and there's a formation of ammonium chloride plus a water molecule is there. That water molecule is not necessary here, but this ammonium chloride will provide you white fumes. There are dense white, it is also known as dense white fumes there, and that dense white fumes gives you the presence of your HCl gas, that your HCl gas is present here. So this is the condition that you can check test for the HCl gas. Just do one thing: dip a glass rod, that glass rod is with your with beta solution of ammonium hydroxide, and this bring that glass rod on the mouth of the jar which is containing your HCl gas. That mouth will containing your HCl gas, just bring it here. Just after this bringing, there is a formation of dense white fumes that are visible by your naked eyes, and that dense white fumes are due to the molecule that is ammonium chloride, and that ammonium chloride is formed by the reaction between ammonium hydroxide and HCl gas, and there is a formation of ammonium chloride there. So by this experiment or by this method you can test for your HCl gas, that this HCl gas is tested by this thing. Okay, so moving on to the next part. So next we talk about few physical properties of your HCl gas, that the properties are defining you that this HCl gas is a colorless gas. There is no color with this HCl gas, it is a colorless gas. Okay, secondly, we are saying that this gas is present with a very pungent odor. Its odor is pungent smell or pungent odor, that is your choking odor, जो गले में जाकर के एकदम से चॉक करेगा, ठीक है, बहुत ही गंदे वाला स्मेल होता है, that is the pungent, बहुत तीखे वाला smell is present there. Next they are saying it is sour in taste. Its taste present is very sour in nature, ये sour taste का होता है. And if we talk about its density, then they said that it is very much heavier than air. This gas is heavier than air, and if we talk about how much in the quantity, it is 1.25 times heavier than your air that is present here. And next is that it is extremely means in a very large amount, it is extremely soluble in water. That quantity is in very large quantity, it is soluble in your H2O, that is your water. So to this point that this HCl gas is highly soluble in water, we are going to take this point here, and along with this point we are just showing an experiment to perform how it can be soluble in this air, how is it can be soluble in the water, that large amount of soluble in the water, and that large amount of solubility is shown by an experiment, and that is known as your fountain experiment that we are discussing in the starting. That is known as your fountain experiment. Very important experiment, completely important, is about its setup, complete setup, its requirements, and how the experiment is performed. That is very important. Directly it can be done with the name of fountain experiment only. So the fountain experiment will tell you about the solubility of HCl in water. Please keep in your mind that fountain experiment will tell you about its solubility of your HCl gas in water, that how this gas is soluble in water. Okay, let's continue the fountain experiment now. Okay, let's talk about the fountain experiment first. Okay, so let's talk about its setup, that how the setup is there present. So we have a big round bottom flask. As you see, this is the round bottom flask present. And with this round bottom flask, there is a glass tube that is connected to the bottom with this solution. The solution, that is the blue litmus solution present in this jar, and that glass tube is connected with this blue litmus solution. This dropper, that is a dropper. I know the shape is not accurate, but that is the dropper present. That dropper is containing water molecules with it, and in this upper portion of this round bottom flask, that HCl gas is present. And you know what? Finally there is a red fountain formed. That the fountain formed is the red one. This is the red fountain formed, and we discussed that how this red fountain will form here, as we want to just discuss about the solubility, that the solubility of HCl gas in water. That's the solubility of the HCl gas in water through this fountain experiment. Now what happened in that case? They said that the end of the tube, this end of the tube is immersed in a beaker. That beaker is containing a blue litmus solution. Okay, that blue litmus solution. Okay, now what we are doing, the very first step, we are just pressing the dropper, and just passing over few drops of water to the few drops of water to your HCl gas. आपने उस HCl gas में few drops of water को pass out किया. As the water mixes with this HCl gas, there is a formation of HCl acid. Okay, the small amount of HCl acid will form, the little moisturizing after getting the little moisture from that. So as this is formed, what happened? The dissolution of this HCl gas with the water take place. And we know this thing, when the acid is comes in contact with a blue litmus solution, then definitely there is a formation of color. There is a definitely change in color. That color changes from blue to red. We know this thing, that its color changes from blue to red. And that red color we are getting from this in the form of this fountain. That this red color coming in the form of that fountain is due to because of this thing. And the very important thing, how this blue litmus comes on the upper portion, because it is present in the downward portion. Then how this blue litmus is coming up on this upper portion, that is the question mark here. So what happened here, the hydrogen chloride gas that is present in the flask gets dissolved in the water. That is a small amount of water is present. When the water dissolves the gas, when this water that we are just passing from this dropper is dissolving the gas, and that dissolution in such a way that the internal pressure inside, the internal pressure that is present inside that flask, your pressure that is present inside that flask pressure will be reduced. We are just reducing, what we are doing, we are just reducing the flask pressure. This flask pressure is reduced, and as the pressure is reduced, that blue litmus solutions comes on the upward portion. And when it is coming in a very small amount with the upward portion, as there is a dissolved HCl acid is present, and then there is a formation of a reaction between this HCl acid and blue litmus solution, and that the color changes from red. And if we are just looking at this red color fountain, and that is a very beautiful fountain originating, that is a red color fountain that we are getting. This is the experiment of the fountain experiment. Okay, we discussed this question, that is the question present that comes on this fountain experiment. As many questions can come, but still one question is there, that is what is the aim of this fountain experiment, is to prove that what is its aim. So the first option is HCl turns blue litmus red. So that we already know that HCl turns blue litmus red. Second is HCl is denser than air. Yes, HCl gas is denser than air, that also we know. And HCl fumes in the moist air, that we also know. But the main point is that HCl is highly soluble in water. So we want to discuss that. We want to discuss that HCl is highly soluble in water. That is the main aim of this fountain experiment, to prove that your HCl is highly soluble in water. So please remind this thing, what is the main aim of the fountain experiment, just to explain that HCl is highly soluble in water. So chalo, let's move on to the next topic. Our next topic is preparation of your HCl. We are discussing the preparation of HCl. So let's moving on the next topic. In the next topic we are discussing the preparation part of this HCl, that is your hydrogen chloride acid. We are discussing its preparatory part. So as you see, there 3 figures are present to explain you about the experimental setup. and we required apparatus. One is the delivery tube. So this is your delivery tube, as it is written here, that is your delivery tube. Second is your beaker, that one beaker you require. Just to explain the setup, I just set up 3 beakers, but actually one beaker only you require. The beaker requirement is one only. One funnel you require, the requirement of funnel is also one. And next reagents, chemicals we required is the HCl gas and the water molecule, that is the water. So the very important part of the situation is that funnel arrangement, how we are arranging the funnel here. Okay, that is very important, because the biggest problem here is about the back suction of water. हम जानते हैं ना that water gets sucked back. अगर water को एक बार तरफ से by the air और by the pressure हम लोग pull करते हैं, the water comes back to us, और वो जो upper portion में water है वो filled up करना start कर देगा. So this is the biggest problem here, the back suction. So we want to avoid this problem for the preparation of our HCl, hydrochloric acid, because the hydrochloric acid is prepared just passing the gas through the water. Okay, we know this thing, that HCl is a highly soluble gas in water, and there is a formation of HCl. वहाँ पे HCl का जो है आपके पास है, and there comes the preparation of HCl will occur after this the solubility. Okay, so just important thing is about the funnel arrangement to avoid the back suction, कि ये back suction नहीं हो, इस चीज को avoid करना है, right? So funnel is put on the water. As such, only just this rim of the funnel will touches the water molecules. This rim of water. So once what happened, when firstly this HCl gas start traveling, okay, then it start traveling, small little amount of water just gets up into the funnel. As you see, this water gets up into the funnel, but as well as the pressure inside and outside the funnel, and the that gap we get between the rim of the funnel and the water equalized. The pressure of the air or pressure is equalized. The water which is going up, the water that is going up here falls down. ये water गिर जाएगा वापस आपके पास में in the water, comes back to again, and the final situation is that the pressure is become balanced. The pressure of the air become balanced in the funnel as well as in the water, upper the rim of the water molecules, and here we get a wide surface area. Such a wide surface area for the gas to contact with water molecules, the gas contacting the water molecules, and it becomes very easy for the preparation of your HCl, hydrochloric acid, because now the surface area of the contact of this gas and the water is increasing on a very high amount, and the gas is, we know this thing, that the gas is easily soluble in water, and then finally there is a formation of your HCl, that is hydrogen chloride acid. So the basic aim to just arrange the setup in such case is just to avoid the back suction of the water molecules, that the back suction is present. So we want to avoid that back suction, कि ये नहीं होना चाहिए of the water molecules inside the funnel. Otherwise water जो है funnel के ऊपर चला जाएगा, and हम नहीं चाहते कि वो ऊपर जाए. So to avoid that thing, we are just taking up this whole setup for that. So that is the preparatory part for the HCl. Next we going to discuss few types of reactions of HCl with the metals, metal oxide, and the बहुत सारी things with them. So let's just have a look on few of the questions that comes on the topic which we had studied yet. तो जो उससे questions आते हैं, एक बार 2-3 questions को हम वो study करते हैं. Let's go on the questions first. Okay, so the question can be done by any way. The first question is action of HCl on the sodium bicarbonate. That we already know what is the action of this HCl on sodium bicarbonate. Actually this question comes on the next part that we are performing in the next video. And the next question is name the drying agent used and justify your choice. What is the drying agent used for the dryness of this HCl gas? कौन सा drying agent को आप use करोगे? The answer is given by you only. Next is set a safety precautions you would make during the preparation of your hydrochloric acid. So what is the safety precaution you want to take during the preparation of your hydrochloric acid? That is also up to you. Now the next question is hydrogen chloride gas cannot be dried over the quicklime. Why? You know what? There is no any difference between this fourth and the second question, because in both the questions, in the second number question he is asking for the directly for the drying agent which you want to use, and in the fourth question, that is hydrogen chloride gas, he is just saying you that why this quicklime cannot be used, because we notice that the quicklime is a drying agent, but why we cannot use this quicklime for the dryness of this hydrogen chloride. So this is all about the hydrogen chloride gas, and this is all about the preparation of your hydrogen chloride gas. Secondly, hydrogen chloride hydrochloric acid and the fountain experiment. I hope you understand what you need to learn and what you need to point out among all the topics. Just learn everything about their experimental setups, about their equations, about their what is the key point in between them, why the arrangement is present there, and what the effect of that arrangement on the preparation of your substance will occur. Okay, so take care till then. See you in your next video, and just do learn that chapter, to start learning this topic from your book. Thank you so much. See you in the next video.